Okay, so next problem, understanding the stereochemical relationship between pairs of, I don't know, pairs of something. So we're supposed to draw the enantiomer of the molecule below. And I'm going to first of all start out, I see the option of saying there is no such thing as an enantiomer right down here. And I don't think this one does, but let's draw it out. Let's first of all say, we'll start with a cyclohexane. I think this will get cleaned up here. There you go. And I'm just going to draw the same thing, except I'm going to draw it backwards. And so draw here, bromine, and there's a bromine. And these are hashes, so they're going out behind the board. And so let's draw them out toward us. And then I look at that and so, you know what? That's the same thing, actually. If I turn it over in space, it's going to, if I'm looking at it from the opposite side, it's exactly the same compound. So I'm going to say this structure does not have an enantiomer. Okay, let's do more practice. Some of these have some, this problem's got some weird instances. Yeah, here's one of them. Okay, so this is a toughie because it's got all this terminology in here, and it's going to make a video this of limited value because what are you going to do? But I guess I'll take this cyclohexane, and I can see that I've got a bromine and a chlorine on it, and they are right next to each other. This is going to be challenging. I probably should build this. So I could see if I could flip it around and make it be the same thing. But because it looks like they're actually, if you're looking down on top from the top of this cyclohexane, the bromine is sort of to the right of the chlorine on the A structure, but it's to the, oh yeah, no, it's still to the right. It's rotated in space. Got it. Okay. All right, so I guess all I have to do is say, are these things on the same side of the ring or the opposite side? And since the bromine is in the axial position and the chlorine is in the equatorial, and they're right next to each other, they're on the same side of the ring. So let's go over to the B structure, and it looks like both of them are equatorial, so they're not on the same side of the ring. So they're not mirror images because only one of them has changed, but they're on the opposite side. They're on the opposite side. So the one is the cis, and the other one's trans. That would be diastereomers. Okay, and diastereomers are stereoisomers and isomers. So let's look at this next one. Okay, cyclohexane with two bromines on it. And it looks like on the A structure, the left structure, they're both on the same side of the ring. And on the B structure, they're not on the same side of the ring. So it's the same thing. We have a diastereomer, and which is a stereoisomer and an isomer. And let's do the same thing here, okay? Both in equatorial positions and opposite of each other, and both in equatorial positions and opposite of each other. All right, I think that's good. Let's see if we have another version of this. No, it's the same version. Okay, so that's all we'll do for this video. You're going to have to build model sets and play around with the terms diastereomers and enantiomers and get this wrong a bunch of times before you really like it. Good luck.